Good morning, and thank you for being here.
My name is Prasert Lukhong. I direct the Cybersecurity Research Center at Thailand's National Cybersecurity Agency, and my work sits at the meeting point of artificial intelligence and security. Today's talk is the story of a single capability curve from generative AI to agentic AI, and toward artificial general intelligence, and what that curve means for two arenas at once: the structure of industry and the security of nations. By the end, I promise you something concrete: a policy blueprint built on zero trust for AI agents, on researcher talent, on international collaboration, and on procurement as a strategic lever.
Let me begin with a single question. Are we ready for an era in which artificial intelligence no longer waits for our instructions, but decides and acts on its own? For decades, software has been passive. It generates only on command, it waits for human input, it is a tool inside our workflow. What is emerging now is different: an active participant that sets its own subgoals, decides for itself, and reaches for tools to get the job done. It becomes an actor in the workflow, not just an instrument within it. Hold on to that phrase, from tool to actor, because that single shift changes everything that follows, for business and for national security alike. These terms, generative, agentic, and AGI, are often used loosely, so let me set them straight, because they are not three separate technologies, they are three stages on one continuum. Generative AI creates on command text, code, images, and it is already deployed at scale across industries. Agentic AI goes further: it pursues a goal within a defined scope, planning, deciding, and using tools on its own, and it is entering production right now. Artificial general intelligence means human-level breadth reasoning across any domain and solving novel problems it has never seen before. Picture a coding agent that plans a feature, writes the code, runs the tests, and fixes its own failures without step-by-step prompting. That is agentic, not merely generative. And notice the arrow along the bottom: as autonomy rises, so do the stakes. That trade-off is the bridge into the security half of this talk. So when does AGI actually arrive? The honest answer is that no one knows, and it matters less than you might think. What matters is that the capability curve is compounding today. Look at the staircase. The generative wave reached the mainstream in 2023 and 2024. The agentic shift is putting autonomous agents into production in 2025 and 2026. Multi-agent ecosystems running end-to-end processes follow later this decade, and the AGI window opens somewhere beyond 2030. Expert forecasts range from around 2030 to well past 2050, so plan for a strategy that is robust to an early 2030s arrival. But the milestones already in production are the direct precursor to AGI. Let me leave you with one line to remember: the preparation window is this decade. Before we go deeper, here is the shape of what follows. The same capability curve lands in two arenas at the same time. First, industry: how autonomous AI reshapes enterprises, work, and competition. Then, national security: machine speed threats, the black box problem, and the case for explainable AI. And in the final section, a strategic blueprint for national resilience and global collaboration. Keep one idea in mind throughout: the technology is the same, what differs is who wields it, and to what end. In industry, the transformation moves through three stages. It begins with familiar business process automation, rule-based tasks, and scripted flows, where humans still make every decision. It advances to agentic orchestration, where AI agents run entire workflows within defined guardrails. And it arrives at the autonomous enterprise operations that optimize themselves, while humans set only the intent and the boundaries. Make that concrete: imagine an agent network that senses a shift in demand, reroutes logistics around a port closure, and renegotiates supplier terms end-to-end, without waiting for a Monday meeting. The executive takeaway is this: the gap between organizations that master agentic orchestration and those that do not will compound. This is a structural advantage, not a simple efficiency gain. What does this mean for people and for work? Let me be honest about the anxiety, because it is real. Routine cognitive work, from analysis to administration, is increasingly automated, and the disruption is both uneven and fast. But the durable model is not wholesale replacement, it is a redistribution of judgment.
Humans set the goals, the guardrails, and the ethical boundaries. AI executes at machine speed within that mandate. For consequential decisions, we keep a human in the loop, and accountability always remains human. Regulators and courts will demand a responsible person, not a responsible algorithm. And there is a policy dimension here. Killing speed is now a component of national competitiveness.
The gains will concentrate in the economies that retrain fastest. This is a policy race, not just a technology race. Now, why won't the market simply solve this on its own?
Consider the private sector arms race. Frontier labs ship capability leaps every few months. Compute investment is measured in tens of billions of dollars, and winner takes most. Economics reward speed above all else. On the other side of that ledger sits the risk, red teaming and evaluation lag behind capability. Models are deployed before their behavior is fully understood, and competitive pressure steadily erodes safety margins. The conclusion is uncomfortable but clear: market incentives alone will not deliver safe AGI. Assurance must become a competitive advantage, not a compliance cost. And if that is the commercial risk, consider what the very same dynamics mean when the stakes are national security.
That brings us to the security battleground.
Cybersecurity is no longer a technical afterthought, it is the core of national strategy, because these threats recognize no borders and they strike critical infrastructure at machine speed.
Energy and utilities, grid control systems probed and disrupted faster than operators can respond.
Finance and markets, autonomous fraud, market manipulation, and settlement attacks at scale.
Health and public services, ransomware and data poisoning against life-critical systems.
Here is the asymmetry that defines this era: attacks move in milliseconds, while human response takes hours.
That gap is the strategic vulnerability.
Cyber capability now stands alongside air, naval, and economic power as a pillar of national strength, and unlike the others, it ignores borders entirely.
So what does the new attack surface look like?
These threats share one unsettling feature: they target the model's cognition, what it has learned, not the code around it. Advanced prompt injection hides malicious instructions inside the data an agent reads, hijacking its goals mid-task, invisibly. Adversarial attacks craft inputs that exploit the model's learned representations, striking at the very core of how it reasons.
Data and model poisoning corrupts training pipelines to implant hidden backdoors that stay dormant until triggered.
An agentic supply chain risk turns every tool, plugin, and API and autonomous agent calls and trusts into attack surface. The lesson is stark: traditional perimeter defenses cannot see any of this.
Firewalls inspect traffic, not thoughts. This leads to the deepest problem in defense systems: the black box.
Follow the diagram: inputs flow in sensor data, intelligence, communications into a model of billions of parameters with no human readable logic, and outcome: high stakes outputs, threat classification, targeting, automated response.
3 failures follow. We cannot audit what we cannot explain.
Bias and manipulation stay hidden until the moment of failure.
And accountability collapses when the logic is opaque. Imagine a system that recommends an escalatory action, and no one in the room can answer the simple question, why?
In defense, that is not a technical inconvenience, it is a crisis of command responsibility. Let me state it plainly: in national security, an unexplainable why is an unacceptable risk.
This is the thesis of my entire talk, so let me deliver it almost word for word. National-grade AI must not merely be smart, it must be explainable, transparent, and accountable.
Explainable, so that its decision logic can be traced, audited, and challenged.
Transparent, so that its capabilities, its limits, and the provenance of its data are disclosed. And responsible, so that a named human owns every consequential outcome.
The reframe for every executive here is this: trust is a design requirement, engineered from day one, not a feature bolted on before launch.
So how do we actually open the black box? That is a research discipline, and it is where academia enters the mission. For the researchers in the room, let me go one level deeper. Mechanistic interpretability means reverse engineering a model's internal computations, neuron by neuron, circuit by circuit.
The techniques are concrete: feature attribution, circuit tracing, activation probing, and sparse autoencoders that decompose representations into human-readable features. The goal is a causal account of why the model produced a given output. And this is a security discipline, not a research curiosity. It lets us detect hidden bias before it shapes decisions, expose implanted backdoors and poisoned behavior, verify goal alignment before deployment, and build structural defenses against adversarial attacks. Explainable AI turns trust from an assumption into a verifiable property. This is the frontier where academia and national security meet, and it is where joint research programs can begin immediately.
And this is not theory. Let me show you 2 peer-reviewed results from our research center, both explainable, verified, and deployed.
The first tackles cybersecurity, a dual verification framework that detects Thai English code mixed malicious scripts hidden in government and university websites, combining a language model with structural statistics under explainable AI guidance. It reaches an F1 score of 0.99, with a false positive rate of just over 1%. The second applies explainable AI to agriculture, classifying mango leaf disease with leakage-aware transfer learning, where GradCAM explains every prediction. It achieves 99.5% accuracy at roughly 25 milliseconds per image on a standard CPU, and it runs today as a live public web application. The message is simple: explainability is not theory. We publish it, we verify it, and we ship it into production.
Now to the solution. How do we secure autonomous agents in practice?
The answer is a zero-trust architecture, built in 4 layers.
First, identity and least privilege. Every agent carries a verified identity with the minimum permissions its mission requires.
Second, continuous verification. Never trust, always verify. Every tool call, every data access, every action is checked in real time. Third, segmentation and sandboxing. Agents operate in isolated enclaves, so any compromise has a contained blast radius. And fourth, auditability and kill switches. Every decision is logged, explainable, and revocable, so a human can halt any agent instantly. Here is the mental model to carry away: treat every AI agent like an untrusted contractor with a badge, never like a trusted administrator.
Assume compromise. Verify everything. Contain by design.
But architecture alone is not enough, because the scarcest strategic resource in this race is not compute, it is researcher talent. We need depth in 2 domains: AI security researchers who can red team, evaluate, and interpret models, and threat intelligence specialists who monitor the global landscape and give early warning for national decisions. And we build that core along a pipeline: attract talent with scholarships and national challenges, train it through specialized curricula and live-fire labs, retain it with real career paths and competitive rewards, and network it into the global research community. A trained researcher corps is the nation's first line of defense, and it is what makes every other measure in this blueprint actually work. And no nation builds that defense alone, because borderless threats demand borderless defense.
Collaboration rests on 3 pillars: shared threat intelligence, real-time exchange of indicators, incidents, and adversary tradecraft across borders. Joint research programs tie in international researchers co-developing AI security methods, shared benchmarks, and co-authored tools. And knowledge and talent exchange, fellowships, secondments, and shared labs that deepen expertise on every side. Let me dwell on that middle pillar, because it is the heart of the partnership. Real, co-developed research is what turns goodwill into capability. The principle is a multiplier: every partner's detection becomes everyone's protection. And to the international partners with us today, this is my direct invitation to you. Let me ground all of this in where Thailand stands. In the ITU Global Cybersecurity Index for 2024, Thailand ranks 7th out of 194 countries, with a score of 99.22 out of 100, Tier 1, role model status. And the trajectory matters as much as the rank: from 44th in 2020 to 7th in 2024, one of the fastest climbs in the entire index, reflecting coordinated work across legal, technical, organizational, capacity building, and cooperation pillars. But here is the harder challenge. Reaching the benchmark is done, the task now is to stay there,
and to convert index leadership into operational AI security capability to lead regional standard setting for secure and explainable AI across ASEAN.
Because the AI era resets the scoreboard, and the next gold standard is AI-specific security readiness.
Credibility, in the end, converts into partnerships, investment, research, and trusted digital trade all follow trust.
So how does government actually move the market? The fastest lever is not regulation, it is demand.
First, procurement as market maker requires security and explainability standards in every public sector AI contract, because demand creates supply. Second, standards and certification. A national secure AI certification aligned with international frameworks, the NIST AI Risk Management Framework and ISO/IEC 42001, so that domestic products are export ready by default.
Third, sandboxes and incentives, regulatory sandboxes, tax incentives, and co-funding that de-risk domestic secure AI ventures.
And fourth, sovereign capability, trusted local supply of models, cloud, and audit capacity, built to global benchmarks. The takeaway is one sentence: government demand can make secure and explainable the market default, rather than a premium feature. Let me bring it together in 3 words you can carry out of this room: transition, threat, and trust. Transition. Agentic AI is the bridge to AGI, and autonomous enterprises will reshape industries within this decade. The capability curve is compounding now.
Threat. Attacks move at machine speed, ignore borders, and target the model's cognition itself, and black box AI in defense is an unacceptable risk.
Trust. Explainable, transparent, accountable AI built by researcher talent and international collaboration is the foundation of national resilience. And one line above all: prepare in this decade, or be reshaped by those who did.
Which brings me to a call to action, addressed to each of you.
To government, mandate explainability and zero trust in every national AI system.
To industry, adopt secure by design AI, and make assurance a competitive advantage.
To academia, grow the researcher talent pipeline in AI security and threat intelligence. Let me leave you with a personal conviction: security and openness are not opposites.
The nations that master trustworthy AI will be the ones the world chooses to partner with. Thank you for your attention. I am Prasert Lukhong, and I would now warmly welcome your questions and discussion.